welcome back to my channel. So this is chemistry question 50 from IMAT 2022 past paper. So let's solve this question. It says which of the following lists given the given elements in order of decreasing first ionization energies. Alright, so in the given of these five options, they have different order, and the main elements they're given is beryllium, lithium, and sodium. So also one thing we should know that for IMATs we have to have brief uh, memorization of periodic table because we're not provided periodic table sheet in the IMAT exam. So we know that the lithium, beryllium, sodium are both alkali metals, so they belong to group 1 and 2. So this is how it is. Beryllium is this side, and adjacent to it, it's lithium, and down it's sodium. Alright, so this is how it is arranged in periodic table. It's in group 1 and 2. Beryllium is in group 2, and lithium and sodium is in group 1. Alright, so we know about the arrangement, and secondly, we have to understand the definition of first ionization energy. First ionization energy. So what's the definition of it is first ionization energy is the energy required to remove 1 mole of electron from outermost shell. So outermost shell are typically the valence electron. So it's the valence electron from, so 1 mole of electron from outermost shell from 1 mole of gaseous gaseous atom to form 1 mole of gaseous ion. Okay, so it's 1 mole of gaseous ion, and so to make it even simpler, we can deduce the equation from it. So it's we can write the simple general equation of first ionization energy. So suppose we have this random element, it's X, it's in gaseous state, it's an atom. So we provide energy since it's endothermic reaction because it requires energy. So this forms an ion X plus gas. So in its gaseous state plus just 1 mole of electron because it is first ionization energy. So now that we have understood the arrangement of this three element lithium, sodium, and beryllium and the definition of first ionization energy, now let's go to these five given options to know which one is in decreasing first ionization energy. All right, so let me raise this off. Okay, so now we have this arrangement. Now we know the trend of first ionization energy. So it typically decreases as we go down the group. So meaning if we go down the group, the ionization energy decreases. Okay, and also if we go from right to left, the ionization energy decreases. And so vice versa, it will increase as we go up and increase as we go to the right. But here we're moving from right to left. Okay. So now why this happens is first we need to construct the electronic configuration of these three elements. So for beryllium, the electronic configuration will be 2, 2, because we're given with these atomic numbers, so we consider them electrons since they're elements and atom. And lithium is 2, 1. So it has the valence electron, the outermost shell, one electron only. Beryllium has two of them, and sodium has 2, 8, 1. All right, so this is the electronic configuration of these three elements given in the question. But now from this, we have to deduce which one has the least ionization energy and highest ionization energy. So we know that uh, directly we can judge that sodium must have the least ionization energy. Why? Because it has the most electron shells. So 1, 2, 3. So it has 3 electron shells. So this more number of electron shells increases electron repulsion effect, which leads to having greater atomic radius. So the valence electron from the sodium, which is this one electron, the outermost shell, is easily removed from sodium atom to form sodium ion. All right, so we know this has the least, consider this the least one. And let's go to lithium. So lithium is, now let's compare lithium and beryllium, since these must have the highest ionization energy since they have the less electron shells, so meaning they have less electron repulsion. But now we have to compare them since both of them have the exact same electron shell numbers. Okay, so the thing is the beryllium has more protons. Since the atomic number is 4, lithium is 3. But beryllium has more protons than lithium. So although lithium has less electrons than beryllium, but beryllium has more protons, so meaning it has stronger nuclear attraction. So this means it has more nuclear attraction, so smaller the atomic radius. So that's the reason why this beryllium has highest first ionization energy, because it requires more energy to remove this 1 mole of valence electron from the outermost shell due to the stronger nuclear attraction from having high protons. But for sodium, even though it has very high protons compared to beryllium and lithium, but it has large number of electron shells, meaning 1, 2, 3, more number of shells, so more electron repulsion for this outermost shell in the third shell. So that's why it's easily removed. But for beryllium, it has least electron shells, even though lithium has the same, but beryllium has more protons than lithium and has less electron shells than sodium. So this is the order we'll go from. So we can mark lithium as medium. So the order we're going to go from is beryllium, lithium, and then sodium. So this is the order from decreasing first ionization energy, beryllium being the highest and sodium being the least. All right, so if we choose which of the option, it's option A. That is correct. Okay, so this is how we solve this question. It's basically related to ionization energy and trends in periodic table. So it's basically easy. So thank you guys for watching my video. I hope you find this helpful. Please leave a like and subscribe to my channel. Thank you guys. Bye.